Today we're going to talk about Chapter 8, Linear Regression. X and Y are observed data values. X bar and Y bar are mean values of the explanatory and response variable data. The standard deviation of X and the standard deviation of Y is the standard deviation of the explanatory and response variable data. Y hat is the predicted value for the response variable based on the regression model. Least squares regression line. Y hat equals BO plus B1 times X, where B1 is R times the standard deviation of Y divided by the standard deviation of X. The regression line can be used to predict Y given X, but not to predict X given Y. If the explanatory and response variables are switched, a new regression line must be calculated. Regression effect. Regression towards the mean. The data value X, that is one standard deviation from its mean, will yield a prediction that can be no more and is usually less than one standard deviation from its mean. This is because R is between 0 and 1, the absolute value of R, that is. See the formula for B1 above to understand why. Residuals. So with residuals, we have data equals model plus residual. So our data is our observed values. Our model is our predicted values, and the residual is the amount not predicted by the model. Therefore, residual equals data minus model, and residual equals observed minus predicted. So we would use the formula E equals Y minus Y hat. The residual line is calculated to be where the sum of the squares of the residuals is the smallest, hence the name least squares regression line. Residual plot, a scatter plot of residuals versus the explanatory variable, or the residuals versus the predicted variable. If the linear regression model is appropriate, the residual plot should appear randomly scattered with 1, no positive or negative direction, 2, no obvious shape or pattern, and 3, no outliers. R squared, coefficient of determination. R squared is the fraction or percentage of the variation in the response variable that is explained by the regression model. 1 minus R squared is the fraction or percentage of the variation in the response variable that remains in the residuals. This is not explained by the model. R squared is always between 0 and 1, or between 0 and 100%. Let's look at example 1. A pizza at Pizza Shack costs $8 plus $1.50 for each topping. So, which statement correctly describes the situation? The number of toppings explains 100% of the cost of the pizza, and differences in the number of toppings explains 100% of the variation in the cost of pizzas. Okay, so let's first graph this. So if I were to graph this, we need to have our scale first, okay? So our toppings, we could have 0, 1, 2, 3, 4, 5 toppings. You could have even more. Me, myself, I don't really like more than 2 or 3 toppings. And then for our costs, let's go up by 2s because no matter what, it's going to cost $8. So 2, 4, 6, 8, 10, 12, 14, 16. So no matter what, we know that our pizza is going to cost $8 because it's $8 plus $1.50 for each topping. So no matter what, our pizza is going to cost $8. So we know that our pizza is going to cost at least this much. Okay, $8. Now, for each topping, it goes up by $1.50. So here it would be 0, and then it would be $1.50. For 2 toppings, it would be $3 additional dollars. So 8 plus 3 would be 11. Then another 150, and then for 4 top-ins, that would be $6. So 8 plus 6 would be 14. So it would go up like this. This is the total cost of the pizzas. Okay. So here in blue, I have the cost of top-ins. And here in red was the total cost of just the pizza itself. So that's the cost of crust, cheese, and sauce. Here, my R equals 1, and my R squared would be 1, or 100%. And the differences in the number of top-ins explains 100% of the variation, keyword there, in the cost of pizzas. So you should have had number 2 to describe that situation above. Let's go ahead and look at example 2. An appropriate linear regression model is found for data comparing the age and sale price of several used cars in a particular European car model. The correlation is 0.9236. Find and interpret R squared. So if the correlation is 0.9236, R squared would just be to square that. And you should get 85.3%. And so that means 85.3% of the variation in sales price of the cars is predicted by the linear regression model with age. Or you could say something like 85.3% of the variation in sales price is explained by the differences in the ages of cars. Or you can also say 14.7% of the variation in sales price is left in the residuals of the regression model. Any of those are equivalent. Regression analysis. The computer printout below gives the regression output for predicting crime rate in the number of crimes per 1,000 population for the number of casino employees in thousands. So this is the computer printout. This will give you the regression equation y hat equals b sub o plus b1 times x. This is your explanatory variable. This is your response variable. Right there, your constant is your BO, and that's B1. So here, this is like your y-intercept and your slope. This is the standard deviation of the residuals. This is obviously R squared because they have RSQ there. And we don't use this value here. And we'll come back to all of these eventually. So we're just going to use this information over here. We're going to ignore the right side for now. So here we have our information. What is the correlation between the number of casino employees and crime rate? So R would equal the square root of 0.974, which equals 0.987. So the correlation is 0.987. Write the equation of the least square regression line. Identify x and y and what they represent. So this would be, y would be your crime rate. So I'm going to write that out. So crime rate. and it's not the actual one, it's the predicted one, so it's crime rate hat, equals my constant negative 0.3980 plus 0.11832 times, and my X would be the number of employees. Give the predicted crime rate for 20,000 casino employees. So this would be crime rate hat, because it's predicted, equals negative 0.3980 plus 0.11832 times 20, because it's in terms of thousands. And we would get 1.968. So that would be 1.97 crimes per thousand population.